Right, students. So now we observe how to construct finite automata for the language. So that language can checks the given binary string is either even or not. So now we are going to constructing some finite automata. That finite automata requirement is to check whenever we pass any specific string through that particular machine or that particular finite automata, then it will decides that particular binary string is either even string or odd string. So in simple logic, when we are going to knowing about even or odd in binary language, the simple thing is, for example, for 0, the binary number is 0. For 1, binary number is 1. For 2, the binary number is 1, 0. For 3, their equivalent binary number is 1, 1. For 4, their equivalent binary number is 1, 0, 0. So from this, so this is the even number and this is even number and this is also even number. So and this is the odd number and this is the odd number. From these two, what we observe, odd numbers are always ends with 1, and from these three, what we observe, even numbers are always ends with 0. So that is a simple logic to design the DFA or finite automata for the checking the given binary string is either even or odd. So that's why here this finite automata can accept the given string means that particular string is the binary. If this finite automata doesn't accept the given string means the given string is not a even number. So that means when the string ends with a 0, then it will go to final state. When the string doesn't ends with the 0, that means either ends with 1, then it go to non-final state. So that is the simple logic. So that's why we starts the construction from q naught when read 0. So go to next state q1. So here itself this is the 0. So that means that is even number. So that's why it was q1 was treated as the final state. And when read q naught from the q naught, when read input as 1, then it must not be final state. So that's why from q naught on input 1 go to q2 state, it is non-final state. From this when we read 0, so that means it was ending with 0, that is 1 and 0. So it ends with 0, so that's why it was going to final state. That's why from q2 on 0 going to q1. From q2 on 1 going to itself only. Why? Because ending with 1 means not a final state or not a even number. So that's why go to itself. So it's a very simple logic. So all ending with zeros are received by the q1 state, and all ones ending with all binary numbers ending with ones are received by the q2, and where q1 is the final state and q2 is the non-final state. So that's why when the binary string is ending with 0, then accepted by the finite automata. When the binary string is not ending with 0, then received by the q2 non-final state. So that means when we pass the binary string through this particular finite automata and it reaches the final state q1, then that particular string is the binary string. When we pass this binary string through this particular finite automata and it reaches q2 finally, then that means that particular string is not a binary and not a even number. So that means that is the odd number. For example, let me check some small number 1010. So actually their equivalent binary number is 2 power 0, 2 power 1, 2 square, and then 2 cube. So that is 8 plus 2. So that is 10. So their equivalent decimal number is 10. So that means actually this is even number. So now let me check, is it accepted by the our finite automata or not. If it is accepted, that means our finite automata construction is good. Otherwise wrong. So now always we starts to check any specific string, always we starts from the initial state. So here initial state is the q naught and first input symbol is 1. Now let me check q naught on 1 go to q2. So that's why next state is q2. Next. Now we are at q2 and second input symbol is 0. So that means it will reach us to the q1. So from here 0 it goes to the q1. So it was reaches to the q1. So now we are in q1 and we read third input symbol. So that is 1. So from q1 on 1 going to Q2. So that's why here Q2 on input 1. So now we are at Q2 and last input symbol is 0. So Q2 on 0 going to Q1. Q1. So when we read the string 1010, finally we reach Q1, where Q1 is the final state. So that means this particular string is accepted. Why? Because this is the even number. So this is the process of constructing the finite automata for check the given binary number is even or not.